Your email inbox decided, this morning, without asking you, whether an email was spam. Netflix decided what to show you on its homepage. Your bank decided whether a transaction looked like fraud. None of those decisions were made by a person sitting there with a rulebook, they were made by machine learning. By the end of this video, you'll understand exactly what that means, not the buzzword version, the real one. No math yet. No code yet. Just the idea, done right, so everything else in this course actually clicks into place. Before we dive in, a quick welcome. I'm really glad you're here. This channel is about learning machine learning the way I wish someone had taught it to me, intuition first, math second, code third, so nothing ever feels like magic. If that's the kind of learning you're looking for, you're in exactly the right place, so let's get started. Here's what this course actually covers. We'll start with the foundations, what machine learning really is and why it works. Then we'll build your first models by hand, from linear regression to gradient descent. After that, we move into the classical ML toolbox, decision trees, clustering, and how to actually evaluate a model properly. From there we go deep, literally, into neural networks, backpropagation, and transformers. And we'll close with practical, career-focused lessons, reading papers, building a portfolio project, and avoiding the mistakes beginners make most often. One quick note on prerequisites: you'll want basic Python. If you can write a function and use a for loop, you're ready. And every single line of code shown in this course is available for free on GitHub, link in the description, so you never have to pause the video to copy code by hand. Here's the traditional way we've always told computers what to do: we write explicit rules. If you wanted a program to detect spam the old way, you'd write something like, if the email contains the word lottery, flag it. If it has more than 5 exclamation points, flag it. If it's from an unknown sender with a link, flag it. Problem: spammers adapt in a week. You're now in an arms race, handwriting rules forever, and you will always be one step behind. Machine learning flips the approach entirely. Instead of you writing the rules, you show the computer thousands of examples. Here are 10,000 emails we know are spam, here are 10,000 we know are not, and the computer figures out the rules itself, based on patterns in the data. That's the whole idea. Machine learning is a program that improves its own rules by looking at examples, instead of a human hard-coding every rule by hand. Let's make this real with the simplest possible example: predicting house prices. Say you have data on 500 houses that already sold, their square footage, and the price they sold for. You plot every house as a square footage on the x-axis, price on the y-axis. Now, a pattern probably jumps out: bigger houses tend to sell for more. A machine learning model's job, in this case, is to find the line that best fits through all those dots. Once it has that line, if I give it a brand new house, one it's never seen, with, say, 2,000 square feet, it can follow the line and predict a price. That's it. That's a machine learning model. It's not magic, it's not a brain, it's a mathematical description of a pattern found in data, used to make a guess about new data. This particular flavor, predicting a number from examples, is called regression, and we'll build one from scratch, by hand, in video 5. If instead you're predicting a category, like spam or not spam, that's called classification. Almost every ML problem you'll ever encounter is one of these two, or a variation on them. Quick question you might be asking: this idea of learning from examples isn't new, so why is everyone talking about it now, in the last 10-ish years? 3 things lined up at once. First, data. The internet generated an ocean of labeled examples to learn from, something that just didn't exist in the 1990s. Second, compute. GPUs, originally built for video game graphics, turned out to be extremely good at the exact kind of math ML needs, and they got cheap. Third, algorithms. Researchers found better techniques, especially for a subfield called deep learning, that could actually take advantage of all that extra data and compute. Take away any one of those 3, and you don't get the ML boom. That's also exactly why some ML problems are still hard. If you don't have much data for your problem, none of this works nearly as well, which is one of the biggest practical lessons in this whole field, and we'll come back to it constantly. Let's not just talk about this, let's see it. I'm going to show you, in about 10 lines of Python, a model learning that house price line I described a minute ago. You don't need to understand every line yet, that's what the rest of this course is for. I just want you to see that what I've been describing isn't abstract, it's a few lines of runnable code. Model.fit is the entire learning step, that one line is where the computer looks at the examples and works out the line for itself. Everything above it is just handing over data, everything below it is just asking a question. That's the whole shape of almost every ML project you will ever build: prepare data, fit, predict. Fast but important, machine learning is not artificial general intelligence, it doesn't understand anything the way you do, and it's not magic that fixes bad data. In fact, the single most common reason real ML projects fail isn't the algorithm, it's messy, biased, or insufficient data. You'll hear me say garbage in, garbage out probably 20 more times in this course, because it's the rule beginners underestimate the most. So, to recap, machine learning means the computer finds its own rules from examples, instead of you hard-coding them. Regression predicts numbers, classification predicts categories, and the whole field only works because of the combination of data, compute, and better algorithms. In the next video, we're going to zoom out one level and walk through the entire ML workflow: data, model, evaluation, iterate, the loop that every single project in this course, and every real ML job, actually follows. If this clicked for you, that video is where it starts becoming practical. Subscribe so you don't miss it, and drop a comment with the first thing you want to build with ML. I read every one, and it shapes what I cover next.